This week, we're going to look at a few tricks that you can use to help speed up making a lot of plots with matplotlib. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I wanted to look at making a lot of plots with matplotlib and some tricks that you can try to speed up that process. Often we have a loop and we're looping through, say, stations or months or days worth of data, and we might always not do that in the most efficient way. Now, there's no one-size-fits-all rule of just do this and your plotting will be faster. You have to try it out for your specific situation. What types of plots are you using? How much data do you have to plot? And so on, because that changes the trade-offs between redrawing certain things or not. So let's go ahead and write a quick example and examine a few of the things that I try. I'm going to import NumPy, import matplotlib, from datetime, I'm going to import datetime. And from pathlib, I'm going to import the path object. So what we're going to do is write a loop that does the same plot. Well, we create random data and plot that random data 10 times, and we're going to take the average time that it takes to do that. So I'm going to create a list called times. For I in range in trials. And let's go ahead and set up in trials up here to be 10 and in data to be 10,000. We're going to create some X data, mp.arange in data. The Y data are going to be numpy.random in data long. Now that we've created our data, we're going to record our start time, datetime.utc now. There's a variety of ways that you can time things in Python. We've talked about some of them before. This is the technique I decided to use today. I'm going to create a figure and an axis using plot.subplots, ax.plot, xdata, ydata, plot.savefig. This is important because saving the figure does take a substantial amount of the time. Temp, and then I, just so each of our files has a different name, .png. And then the end is datetime.utc now. Now we're going to append to times the end minus the start, and we're going to get the microseconds. So that's the microsecond time delta between these two events. And then after we've done our number of trials, I'm going to print the mean of those times and divide by 1e to the 6. So we get seconds. And finally, we need to remove the files that we just created. So I'm going to call a function remove files that we need to go ahead and write. That way each trial is starting from an empty directory. So we're going to define our function remove files. It's going to remove test files. And we're going to loop over for I in range in trials. And we will take in trials in. We're going to create an instance of the path object that looks like our file name. So tempi.png. Then we'll call unlink to remove it. So now we run this cell. And it's going to churn for just a second. It says we're missing our required argument in trials. And now you see we get all of these plots here, which is not super convenient. We don't really want to display those in the notebook. So we're going to go ahead and up here we'll switch to the AGG or AG backend, which will keep things from showing up in the notebook. Okay, now as you see, that did slow things down a little bit. So backends are one thing to check. Are you using the fastest backend for your particular application? Do you only need to write a PNG or do you need to write vectors as well? But we're going to continue with AGG, though I encourage you to experiment with different backends and trying different techniques. So now I'm going to copy this block. This isn't good coding practice, of course, to just copy and paste big blocks of code, but we're going to do that so we can compare them directly. All right, so this next trial, I'm going to take my figure and axis creation outside of the loop. So I'm only going to create the figure and axis once. And then after I save fig, I'm going to call ax.clear to clear the axis, and then we'll reuse and plot on that. And okay, 0.464. So that saved us a very small amount of time, just about 5 milliseconds. 5 milliseconds isn't nothing, especially if you're doing a lot of plots, and this is a relatively simple plot, but it didn't save us a lot. Let's go ahead, copy and paste, and try to improve again. In this case, I'm going to save a reference to the line that I plotted as L. I don't need to use ax.clear anymore. Instead of doing the plot here, I'm going to call L.set ydata. This is assuming that all of our x's are the same, to be ydata. And we'll move the actual plot line out of the loop. So initially, this is just going to use whatever's left over in xdata and ydata variables, make a plot. Then we're going to come into our loop, generate new data, set the ydata on the line so our line will change, save the figure, and then go on again. So we're not recreating the .plot instance, that line, and we're not recreating the figure and the axis each time. And that saved us a little more. That saved us another 40-ish milliseconds. But that's still not the biggest improvement we can make. I'm going to go ahead and paste this block up here. Instead of calling ax.clear, we can try using plot.clearAxis. You say, well, this seems like it's going to be the exact same thing. Maybe it is, but maybe it works a little differently under the hood. So 0.463. 0.464. So those are basically the same, but it was worth a try. Now let's try .clf. So this clears the figure. So we're reusing the figure, but we're wiping everything off of it. And interestingly enough, this actually runs the fastest. We're down to 57 milliseconds. That's something like an 8-fold time savings here. Now, why does clearing the whole figure instead of just clearing the axis work in this situation? That's a great question. Sometimes I've got better luck by doing a complete figure clearing. I think instead of actually deleting all of those ticks because we're now changing where the tick marks are maybe, or we're changing the range of something, sometimes it is more efficient to just clear the whole figure and start again. So these are a few of the things that you can try. I have found that setting the x data and y data, like we did right here, works very well on scatter plots often, as opposed to line plots, where it doesn't seem to save me that much. But trying a few of these tricks and benchmarking your plots before you put some big loop out there that's going to make 1,000 plots that you need to thumb through, this can save many minutes or sometimes even hours while you're waiting for your code to run. I hope that you found this useful, and I'll see you on next week's MetPy Monday.